So I've alluded to the idea of resistance to electrical flow. We'll now study that a bit more in depth. This lecture is on electrical resistance. Electrical resistance is given the symbol of capital R, and it's measured in a unit known as ohms, which has a symbol of omega, and that's the shape of it there. When we talked about the element, the heating element on a stovetop, you could see that the element was resisting the electric flow, and through that resistance, energy was transmuted from electrical energy to heat and light energy. This is the same idea in a toaster or in any type of electrical device. Electrical resistance is the degree to which the substance resists the flow of electric current through it. It's measured in ohms, and you may also want to add that it's through electrical resistance that energy is transmitted or transmuted from electrical to another form of energy. You might have seen these little devices on electric circuit boards. They are known as resistors. The symbol for a resistor on a circuit diagram is kind of a squiggly line. That's the North American style. You might see the European style is just a rectangular box. Resistors come in different kind of forms. You can have resistors that change their resistance, known as potentiometers. You can have resistors of this type here, which are the most common, that can be read using a color code. And you can have resistors that have different tolerances as well. So a resistor really is any type of material that slows current flow. In circuits and electronics, resistors are also used to control the current flow as well. But a load, basically, something that you're using, an electrical device you're using, is also a type of, it can be thought of as a resistor as well. We can measure the amount of resistance. It says here, so to measure the amount of resistance that a quantity of moving charge encounters, we can compare the electric potential difference the charge experiences as it passes through a load to the amount of electric current. So there is a relationship between the electric current and the voltage drop across a resistor. And if we graph those, we would see a linear graph where as the current increases, the voltage increases at a linear rate. The slope of the line is the resistance. And German physicist George Ohm was the one who determined this ratio, and he called this Ohm's Law. It's stated algebraically as V equals IR. So most resistors are what we call ohmic, that follow this kind of linear relationship in terms of how their resistance increases. But there are some non-ohmic resistors as well that have different voltage current graphs. So Ohm's law is V equals IR. There's also the Ohm's law triangle, VIR, where we have V equals IR, I equals V over R, and R equals V over I. V is, of course, the potential difference in volts. I is the current in amperes, and R is the resistance in ohms. So here's a simple question. It says, what is the potential difference across a toaster with a resistance of 13.8 ohms and a current through it of 8.7 amps? So we will solve this just with our calculator here. So our equation we would use, we start with V equals IR, and our I is 8.7, our R is 13.8, so 8.7 times 13.8, it's not working here, 8.7 times 13.8 gets us to 120 volts. Next question. What is the resistance of a load with a voltage of 25 and a current of 410 milliamperes? So starting with the equation V equals IR, we can rearrange that to R equals V over I, so that's 25 divided by 0.410, and that gets us to 60.97 or 61 ohms of resistance. In a circuit where voltage is kept constant, state what happens to the current if the resistance is doubled, quadrupled, or halved. Well, so we have V equals IR, so if we cut the, if we double the resistance, sorry, we're asked about state what happens to the current. So V equals IR means we rearrange that to I equals V over R. So if the resistance is doubled, our current gets cut in half. If the resistance is quadrupled, the current gets cut in a quarter. And if we have the resistance, it would be like dividing by 0.5, which is the same as multiplying by 2, so the current would be doubled in that case. This here, I'd like you to try this out. It's a simple equation, V equals IR, just rearranged. You can substitute the values in black and try to solve for the answers that are in red. So here's a question. It says, explain how you would experimentally determine whether a resistor is ohmic or non-ohmic. You can measure the current through the resistor at various voltages, plot the V versus I graph, and see if the line is linear. If that line is linear, we know we have an ohmic relationship. So our voltage, or sorry, our resistor would be considered to be an ohmic resistor.